3 and 8/9, really close to the value of 4. And then for my last point, so impossibly close, it almost touches. Alright, we'll go ahead and connect it. Okay, and notice this one's going to take off very fast. So let's go ahead and put in a couple of quick notes as far as what we're going to get for each function. Let's go ahead and take a stretch break for a moment, maybe pause the video, stretch. Okay, hopefully you've enjoyed stretching there. Alright, and if you didn't, hopefully you're able to stretch in your seat as we're going on. Alright, so I want everybody to write this in their notebooks. Alright, so we're going to have exponential functions, and we're going to write something that just gives us a little bit of a literal understanding. Nice literal equation. They're going to take on the form of f of x equals a to the x plus b. Alright, at least at this level, that's what we're going to have, or at least for today. Occasionally, there will be a number that we are going to multiply out in front. Some of you may even remember that we wrote these as something like b times a to the x plus c. But for now, we're not going to be looking at multiplying some number out in front. Maybe eventually, but not today. Alright, and what we're going to care about here is a as our base, and it is going to determine the steepness of our graph. Sort of like how when we had a linear function, our slope would determine how steep our graph is. The base is what is going to determine how steep and how fast our function takes off. An example of this, 3 was steeper than 2. We graphed a couple of examples where we had bases of 2 and 3, and all of our graphs that had 3 as the base, they were steeper. So the bigger our a value, the steeper our graph will be. And then for b, that is going to be our vertical shift. And along with being our vertical shift, another word that we can use be our asymptote. Okay, so the asymptote, which, go ahead, grab another sheet here. Real quick, I'm going to spell that out a little bigger so that we can have everybody see how we spell it. It's going to be A-S-Y. And let me actually just make sure I get this right. I'm going to just refer to my notes real fast. How embarrassing. Math teacher, and he's not even quite sure. I've been doing it wrong all night. Okay. A-S-Y-M-P-T-O-T-E. Okay. I'm going to have everybody write that down. Alright, so asymptote. And just remember, your graph can't touch it, but it can get close. Alright. If it touches, then that's bad. But it can get close. That's okay. The closer you get, more danger there is of touching. But as long as the graph does not touch, then you are okay. Alright. With that, let's have you guys identify for me a couple of examples here. What is the asymptote? Okay, what is the asymptote for the following problem? Let's take a function like f of x equals 5 to the x plus 15. Alright, now this one we don't have to go and get all the table of values, we just have to find what is the asymptote. Alright. Go ahead, take a moment, look it over. What do you think? We'll look back a little bit, we'll say, alright. Right here we had a lovely set of notes that said the number, the one that's not the base, that is our asymptote.